All right, here's 14.4 example number 2. Find dy over dx, the derivative with respect to x. All right, I don't know about you, but I'm noticing a red flag on this one. Remember, anytime we see that square root, we can take those and we can change them. So instead of calling him the square root of x times the square root of y, can we call him x plus x to the 1/2 times y to the 1/2 equals y squared? All right, now let's practice your implicit differentiation, making sure you use product rule for that middle piece there. Try it, pause your video, see if you get the same thing I did. Woohoo, okay. I got 1 plus x to the 1/2 times 1/2 y to the negative 1/2 dy dx. That's the power rule with implicit differentiation. Plus my y squared times 1/2 x to the negative 1/2 equal to 2y dy over dx. That's product rule with a couple power rules in there with my implicit differentiation. All right, I see some negative exponents. I see some fractions. I'm going to try to make that look as nice as possible. So try moving all of your stuff around and see if you get the same thing I did. I have a 1. I have a x squared on top. I have a 2 on the bottom, and I'm going to bring this y to the negative 1/2 down to the bottom as well. I have my dx over dy over dx next to it. In this next term, I have a y to the 1/2 on top, I have a 2 on the bottom, and I'm going to bring this x to the negative 1/2 down to the bottom. So hopefully you're down to the purple step with me. So now I notice that I have dy dx's in a couple of different spots, but I also have fractions on this problem. And I don't know about you, but I'd like to clear those fractions first before I do anything else. And so what I'm going to do is I'm going to clear fractions, and hopefully we know how to clear fractions in an equation by multiplying every term in there by the common denominator. Okay, so this one has a denominator of 1, I have a 2y to the 1/2, I have a 2x to the 1/2, and then this guy just has a 1 on him also, right, as his denominator. And so what would be my common denominator? Well, it looks like my common denominator is a 2, is an x to the 1/2, and a y to the 1/2. So that's what I'm going to do. I'm going to multiply every single term in here by a 2, by an x to the 1/2, and by a y to the 1/2. Okay? I just noticed. Oh, look what I did in my orange. I moved my dy dx's to the same side first. And that's okay. You can do it in any order. So it looks like that's what I did. I moved my dy dx's to the same side, and then I distributed through my common denominator to clear fractions. So 2 x to the 1/2, y to the 1/2 times 1 gives me a 2x to the 1/2, y to the 1/2. When I distribute it here to the y to the 1/2, remember the 2 on the top, you see this 2 on the top goes with the 2 on the bottom, right? They reduce each other out. I've got an x to the 1/2 on top and x to the 1/2 on bottom. Shouldn't they also reduce each other out? And then I have a y to the 1/2 times a y to the 1/2. Isn't that y to the 2/2, or can I say just y to the first? Okay, make sure you understand how I got those values there. Okay, I'm going to do it again to every single term. When I multiply it over here, I have a 2 times 2. That's how I got the 4. I have an x to the 1/2. That's how I got my x to the 1/2. I have a y to the 1/2 times a y to the 1, or 2/2, right? Which gives me y to the 3/2. When I multiply, I really add the exponents. I'm going to do the same thing with my last term. The 2 on the top, the 2 on the bottom, cancel. The y to the 1/2, the y to the 1/2, they also reduce and cancel. Then I have an x to the 1/2 times another x to the 1/2 is really x to the 2/2, or can I say x to the 1? And don't forget I have a dy dx over there as well. So now that my dy dx's are already to the same side, I can then GCF out that dy dx, and then I can divide that chunk off. I ended up getting dy over dx equals 2x to the 1/2, y to the 1/2 plus y, all over 4x to the 1/2, y to the 3/2 minus x. Not very cute, but still a derivative. Still an instantaneous rate of change. Still the slope of my tangent line. Okay, I'm going to go ahead and skip B. I think that last one was complicated enough, but I would like you to practice that. You might have some complicated ones on your homework just to kind of get you going. Make sure that you understand how to do your implicit differentiation when it's not always so simple. Okay, I'll save that last example for our next video. Hope you guys